All right, notes for section 7.4. The 7.4 stuff is very similar to what we did yesterday with just some minor differences. Yesterday we talked about things like the sine of x plus y, okay? And cosine and tangent also. Today what we're going to talk about, they're called double angle formulas. And double angle formulas are going to be things like the sine of 2 theta or 2x. So the first one we are going to do is the sine of 2x. And the first thing we're going to do is change that. Instead of 2 theta, we're going to change it into theta plus theta. That's the same thing. Now that we have this, we're going to use the formula that we used yesterday, and the formula was sine, cosine, cosine, sine. So we're going to change that into the sine theta, cosine theta, plus cosine theta, sine theta. Yesterday they were x's and y's, and they were two different variables. Today they're the exact same variable both times. Now you might notice those two terms are exactly the same. They're just kind of flipped backwards. So that equals 2 times sine theta cosine theta. And this is your first double angle identity. The double angle identity for sine is that the sine of 2 theta equals 2 times sine theta cosine theta. We are going to go through that exact same process for cosine and that exact same process for sine, or tangent, pardon me. So double angle formula for cosine. Start with the cosine of 2 theta. Change 2 theta into theta plus theta. Use the identity from yesterday. Cosine, cosine, sine, sine, change the sign. So cosine, cosine, sine, sine, and change it to a minus on the inside. Cosine times cosine is cosine squared. Sine times sine is sine squared. So the double angle identity for cosine is cosine 2 theta equals cosine squared theta minus sine squared theta. This looks similar to, but it's different from the Pythagorean identity. Remember that was sine squared plus cosine squared equals 1. In this case, we're subtracting, not adding, so we get a different value. It doesn't equal 1, it equals cosine 2 theta. Now we can use this Pythagorean identity to get a different version of this same formula right here. So for example, I could say cosine equals 1 minus sine squared. Cosine squared equals 1 minus sine squared. And I can substitute that into the formula. So I'm going to take this and substitute it in right there. Then I would get another double angle identity is 1 minus sine squared minus sine squared. And since I'm subtracting the sine squared twice, another way to say that is 1 minus 2 sine squared. So that's another version of the double angle identity for cosine. This says if we substitute in 1 minus cosine squared for sine squared, or like we just did, substitute in 1 minus sine squared for cosine squared, we'll get two alternate identities for cosine 2 theta. One of them is the one we just did. The other one would be 2 cosine squared theta minus 1. When I am solving things and doing identities, the only one that I ever remember is the first one. But it's good to be aware of the fact that if you use the Pythagorean identity, you can change that original one around and get two more identities that are also true for cosine 2 theta. So we did double angle for sine, double angle for cosine, now double angle for tangent. Change the tangent of 2 theta into tangent of theta plus theta. Now we'll use the identity from yesterday and plug in the thetas everywhere. And simplify. On the top, we have tangent plus tangent, so that's 2 tangent. On the bottom, we have 1 minus tangent times tangent, so 1 minus tangent squared. That is the double angle identity for tangent. Now the notes that we just did explained where the formulas come from. What you need to know is what the formulas are. So here is one condensed version of all of the formulas and all of the identities that you need to know from today. You need to memorize the sine one, memorize at least one of the cosine ones, and then like we said, it's helpful to use the Pythagorean identity to get the other two. The tangent identity I will give to you on the test. So you do not need to remember the tangent identity. Now what I'm going to do on the test, I will give you this one. But once you have that one, you can do the double angle one, no problem. So yesterday I told you I would give you this identity for tangent. Once you have that, you need to be able to use it to get the double angle for tangent. So I'm not going to write this exact formula on the test. I'm going to write the one from yesterday on the test, and you have to be able to use it to get this one. Let's do some examples using this. So example 1, if the sine of theta equals 2/3 and theta has its terminal side in the first quadrant, find the exact value of each function. First value that we're supposed to figure out is the sine of 2 theta. So I'm going to start with the formula. The sine of 2 theta is 2 sine theta cosine theta. So that's going to be 2 times, the sine theta is 2/3. We know that. We were given that up in the problem. We need to figure out the cosine of theta. So to figure it out, I'm going to use this given information to draw a triangle. That triangle has an opposite over hypotenuse of 2/3. Use the Pythagorean theorem to solve for that last side. That last side is the square root of 5. So the cosine adjacent over hypotenuse is square root of 5/3. Now I can multiply straight across. 2 times 2 times the square root of 5 is 4 times the square root of 5. 1 times 3 is 9. Being careful of positives and negatives, they are telling us in the problem that the terminal side is in the first quadrant. In the first quadrant, everything is positive. So my answer is going to be positive. Next one, cosine 2 theta. The formula from today, cosine squared theta minus sine squared theta. And I already figured out, sorry about that, I already figured out the values for cosine and sine. Cosine is the square root of 5/3, so I'm going to square that, minus sine was 2/3, I'm going to square that. So that's 5/9 minus 4/9, which is 1/9. Same idea, this time with the tangent of 2 theta. Tangent formula for 2 theta was 2 times the tangent over, there we go, over 1 minus tangent squared. So I'll go back to my triangle. The tangent opposite over adjacent is 2 over the square root of 5. So I'm going to do 2 times 2 over the square root of 5. And I could rationalize that now, or I could rationalize it later. I'm going to choose to rationalize it later. Over 1 minus tangent squared. I definitely want to wait to rationalize this one until later, because when I square it, I'll get rid of the square root anyway. On the top of this fraction, I have 4 over the square root of 5. I'm going to rationalize that in a minute. Over 1 minus 4/5. So that's 4 over the square root of 5 over 1/5. To get rid of the fraction in a fraction, I'm going to multiply by the reciprocal. So I get 20 over the square root of 5. Now, like I said, you could have rationalized from the beginning. I'm choosing to wait till the end to rationalize this fraction. And I'm going to get 20 square root 5 over 5. But that reduces to 4 square root 5. Cosine of 4 theta is our last example like this. This is different. We don't have a specific formula for what the cosine of 4 theta is. But the cosine of 4 theta could be rewritten as the cosine of 2 times 2 theta. We had a formula from before that said the cosine of 2 times something equaled cosine squared of that something minus sine squared of that something. That's the formula from earlier today. So 2 times something equals the cosine squared of something minus the sine squared of that something. In this case, our something that's being multiplied by 2 is 2 theta. So I'm going to put 2 theta in everywhere this formula had just a theta. So I'm going to say this equals the cosine squared of 2 theta, because that's my something, minus sine squared of 2 theta. I put 2 theta into the formula everywhere it used to be theta. Now this would be a really long process. I'd have to use the double angle formula for this again, but I already figured it out. I figured out that the cosine of 2 theta was 1/9 earlier in the problem. So I just need to do 1/9 squared. Minus the sine was 4 square root 5 over 9 squared. Square them both, multiply it out to finish that one, and then we'll do the half angle formulas in a minute.